Today we're going to be talking about polyatomic ions, and they're used in a lot of acids, and that's why we're going to be talking about them, because they deal with a lot of other bonds later, more abstract bonds, that have more than just two atoms bonding to each other. Now, the first thing you must know is what is a polyatomic ion, and it is a covalent bond between nonmetals that forms an ion overall. So the polyatomic means multiple atoms, and the ion refers to the multiple atoms bond, but they don't make a balanced neutral atom or neutral compound like most like NaCl would. They bond covalently, so that's how you usually have nonmetals in covalent bonds, and they form an ion overall, so a charged particle. It could be negative, it could be positive, and then this leads to them then bonding to other atoms with opposite charges or opposite charges. So if it's a negative bonded, it would be bonded with a positive charged atom to form bigger and more complex compounds. Now, a good example of this would be cyanide, which has one carbon atom and one nitrogen atom, and they bond covalently to form an ion with a -1 charge. And if you look at sodium, sodium has one electron in its octet, outer electron shell, or one valence electron. And so cyanide, because it only needs one more electron to fill it, takes it away from sodium, and sodium now has a positive charge. And this leads to them both, because cyanide ripped the electron, sodium has a positive charge, cyanide has a negative charge, they then bond ionically. Now here's a big list of common polyatomic ions, and if you're in AP chemistry or college chemistry, you need to basically memorize all these different ones. And we'll talk in a few other slides about how the naming structure of these usually works. So the naming structure of polyatomic ions with relation to each other usually works and starts with, you first, 8 is the root word, meaning everything is named according to the polyatomic ion that has the suffix 8. And so in this example, you have chlorate, which is equal to ClO3 with a -1 charge. So talking about the root, so what does that mean? So if you add one oxygen to chlorate, the root and base compound, or polyatomic ion, if you add one oxygen to it, you get perchlorate, because you add the perchlorate, prefix to it. If you take one oxygen away from the root chlorate, you get chlorite. You change the suffix 8 to ite. And if you take chlorate and take 2 oxygen from it, or you take chlorite and take 1 oxygen from it, you get hypochlorite, where you both change the prefix to, and you add the prefix hypo, and you also add the suffix ite instead of 8. So that was with oxygen. Now what about hydrogen? So if you add 1 hydrogen to a polyatomic ion, you add the word hydrogen before the ion name, and you add a prefix before hydrogen depending on how many hydrogen you add to the ion. Now for an example, we have a polyatomic without a hydrogen, so there's no hydrogen in the name. Sulfate equals SO4 2-. There's no hydrogen anywhere because there's not in the atom. Now, the next case, you added 1 hydrogen to phosphate, So then it becomes hydrogen phosphate equals HSO4 minus. And then another one is that you add 2 hydrogen to phosphate. So again, you use those the prefix naming thing that we talked about in covalent and ionic naming. So now it would be dihydrogen phosphate equals H2PO4 minus. Thing I want to talk about before I close off this video, and it is that adding oxygen and hydrogen or taking away oxygen could change the charge of the polyatomic ion. So it doesn't have to remain its same -1 charge or -2 charge. It could change. So you have to keep that in mind. And it could change independently. So if you look at one that one oxygen is added and it changes for one polyatomic ion group, like sulfate to sulfite or something like that, it might not work for chlorate to chlorite. It might not be the same charge change that occurs. So you have to keep that in mind. And I would reiterate that you should memorize the list explained earlier in the video. Okay, thank you and goodbye.